Let's talk about something that, and I mean this quite literally, built our entire modern world. It's the unsung hero we almost never see. Today, we're going to dive into the fundamentals of the transistor. So, let me ask you a question. What do you think is the single most important invention that you've probably never ever seen with your own eyes? And no, I'm not talking about the wheel or the printing press. Nope. It's something much, much smaller. But here's the thing. It's everywhere. It's humming away inside your phone right now. It's in your computer, your TV, even your car. I mean, it is the invisible engine powering pretty much our entire digital lives. So, what is this incredible, mysterious little device? Well, it's the transistor. And for all the complexity we associate with modern electronics, this thing, it really only does two fundamental jobs. That's it. It acts as a switch, and it acts as an amplifier. Okay, so the official definition says a transistor is an active electronic component. Now, that word active is super important. See, unlike a resistor that just, sits there and resists current, a transistor actually does something with the electricity it gets. It's got three little legs or connections that let it control the flow of power: a small input, a big current source, and an output. So yeah, everything a transistor does, and I mean everything, boils down to just these two jobs. On one hand, it can be an amplifier, taking a tiny little signal and boosting it into something much, much bigger. And on the other hand, it can be a switch, turning a current on or off, literally billions of times a second, with zero moving parts. It's wild. Okay, that amplifier thing might sound a little abstract, right? So let's use a super simple analogy that's going to make this all click. All right, let's look at the technical side for just a second. You've got a small current that goes into what's called the base. Think of the base as a kind of gatekeeper. When that small current is there, it opens the gate and allows a much, much larger current to flow from the collector through to the emitter. So the bottom line is, a tiny little input controls a huge output. Still with me? Okay, now for that analogy. Just think of a transistor like a water faucet, right? The tiny amount of effort it takes you to turn the handle, well, that unleashes this massive flow of water from the main pipe. A tiny little action controls a huge result. That right there is amplification in a nutshell. So a single transistor is pretty neat, but the real magic, the thing that changed the world, is what happens when you start linking them together. This is where things get, well, really powerful. Okay, check this out. In this circuit, we're taking the tiny, tiny electrical current from a human finger and using one transistor to amplify it enough to light up an LED. And as you can see, the result is pretty underwhelming, right? The light is super dim. One transistor just doesn't do a whole lot on its own. But now, what happens if we use three? See, the output from that first transistor becomes the input for the second one, and the output of the second one feeds into the third. It creates this incredible cascade effect, and suddenly that same tiny current from a fingertip makes the LED blaze to life. The effect is just enormous. So just how enormous are we talking? Well, let's say each of these transistors has what's called a gain, an amplification factor of around 200. So after three of them, the total amplification is 200 times 200 times 200. That is 8 million. That's the mind-boggling exponential power we're talking about. A signal that was basically nothing becomes a massive usable current. Okay, so that's amplification. Incredibly powerful stuff. But the transistor's other job, its role as a switch, well, you could argue that's what really changed the world. This simple on-off function is the absolute bedrock of our entire digital universe. So, as a switch, a transistor has two basic states. When it's off, no current gets through. The gate is closed. But when you send a little signal to it, it turns on and current flows freely. The gate is open. It's a perfect, flawless switch with no moving parts to wear out, and it can flip between on and off billions of times per second. And I love how the source material puts this. It's just so direct. It is the basis to all digital circuits. And that is not an exaggeration, not even a little bit. This simple, reliable switching action is, well, it's everything. So why? Why is it the basis for everything? Because those two states, on and off, are the physical way we represent binary code. On represents a 1, off represents a 0. And with ones and zeros, you can represent, well, any piece of information you can possibly imagine. A word, a picture, a song, it's all just ones and zeros. And when you combine millions or now billions of these tiny little switches, you are literally building the logic of a computer. So let's bring it all home. It's just two jobs, two simple functions: amplifying a signal to make it stronger and switching a signal on or off to represent information. That's it. But it's doing these two things at a scale and speed that is almost impossible for our brains to even comprehend. And that is what makes everything from your smartphone to space exploration possible. And this brings us right back to that idea of exponential power. We saw what happens when you go from one transistor to three. Then we talked about millions of them building a computer. But today's chips, they have billions, even trillions of them. So it leaves you with a pretty big question, right? If one transistor is a switch and millions make a computer, what are we going to build next with billions more?